guys, welcome back. This week we're going to do a review on surveying. This is part 1. Next week we're going to work on part 2. Just a quick reminder for all of you who have not yet subscribed or liked or comment this video, please do so this video can reach more people just like you. Ready? Let's start. A closed traverse ABCD is shown below. Which of the following statements is incorrect? So pay attention, we have to find the incorrect statement. So I have 1 incorrect and 3 of them are correct. Let's see. A, the latitude of line AD is negative. So how do we find the latitude of line AD? I would go to FE handbook and go to to remind you where do you have the information on latitudes. So you have surveying information under the civil engineering, transportation, and I know it's all the way at the end, so I'm going to go to environmental and just go up a little bit. Okay, construction, and here we have the surveying information. And the question is asking the latitude of line, or the statement is the latitude of line AD is negative. We have line AD over here, and this, if this is north, right, this would be south, west, east. And now we have line AD in 4th quadrant, right? This is 1, this is 2nd, this is 3rd, and this is the 4th quadrant. And going back to the FE handbook, here in the 4th quadrant, line AD is something like this. And so this is AD. And notice how in the 4th quadrant, latitude is negative indeed. So this statement is correct. So I'm going to do a mark like this. Next, B says the sum of the latitudes for all 4 lines is equal to the sum of all departures. So what does that mean? We know that the sum of the latitudes for a perfectly closed traverse is 0. Same is true for the sum of all departures. For a perfectly closed traverse is 0. So the sum of the latitudes is equal to the sum of all departures because they're both equal to 0. So this one is also correct. Next, let's see. The bearing of line AD is south 23 east. Again, AD, we're going to address AD. We know is in southeast quadrant, right? This angle here is 67, which means that this angle is 90 minus 67, which is 23 degrees. And again, we know this angle is equal to this angle, and this one is also 23 degrees. So it seems that the bearing of line AD is indeed south 23 east. So C is also a correct statement. Let's look at the D statement. The azimuth of line BC is 73 degrees. Let's go and find BC. So this is BC. And the azimuth, remember we talked about azimuth. Azimuths you start to measure the angle from the north all the way to your line. So this is the angle. And notice how this angle is greater than 90 degrees. We're going to have actually, we know exactly how it is. How much it is. It's going to be 180 degrees minus 17 degrees because we know this angle over here. So this is going to be an angle which is greater than 90 degrees, which obviously here the azimuth it says that is 73. 73 is less than 90 degrees. So D is our incorrect statement, which means D is our choice for this problem. Great, let's move forward. electronic distance measurement instrument is used to sight a prism located at station B. The distance is measured as 234.78 meters, and the zenith angle is 73 degrees, 32 minutes, 30 seconds. If the height of instrument, mistake here, is 565.23 meters above sea level, what is the elevation of the prism at B? Neglect curvature and refraction effects. Okay, so let's see if we can sketch this a little bit to be able to see exactly what we're asked. It seems we are somewhere at point A. We have our instrument. I'm going to say, okay, this is A. All right. And somewhere we are measuring, we have a prism. I'm going to draw it like this. Anyway, it goes farther, but it doesn't matter. So this is somewhere here, right? I'm going to say this is point B. So the problem says the distance is measured from point A all the way to point B. So we're measuring A all the way to B. And this distance is set to be 234.78 meters. And then we're also given the zenith angle is 73 degrees. And remember how zenith angle is a vertical angle. So the angle measured from the vertical line to our distance from A to B. And this angle is 73 degrees, 32 minutes, and 30 seconds. Okay, we also are given the height of instrument is 565. I'm going to come back here. So here we have the elevation on top of the height of the instrument, which is 565.23 meters above sea level. What is the elevation of the prism at B? So we are asked to calculate this elevation at B. In order to calculate or to find that elevation, I'm going to draw or continue that line all the way to this vertical line. And now notice how we have a right triangle here. So in other words, we're going to have to calculate this distance. Let me call this distance x, which is this distance from here to here, right? This is x. I can show it from here to here. This is my distance x that I have to calculate. And the elevation at B, so elevation at B is going to be equal to elevation of height of instrument plus x. So let's calculate x. In this triangle or right triangle A, B, I'm going to call this C. I know the angle and I know the distance, hypotenuse. I can use the cosine and calculate for x. If I apply cosine of the zenith angle, let's say this is going to be equal, which this is the zenith angle, I'm going to call it z. This is going to be equal with x divided by 234.78. And from this equation, I can calculate for x equals 234.78 multiplied by cosine of z, which is, let's say, 73 degrees, 32 minutes, and 30 seconds. And now do the same. Please use your calculator. I'm going to use mine. And let's see how much is x. So I'll have this angle. Maybe I should do it separately here. This angle of 73 degrees. Let's remind you how we do that. In order to calculate we know that 1 degree is equal to 60 minutes. Also, 1 degree is equal to 3,600 seconds. So in order to calculate for that angle, we're going to have 73. Excuse me, let me start all over. So we have 73 degrees plus 32 minutes. In order to transform this to degrees, we're going to divide it by 60 minutes. Plus, we have 30 seconds. In order to transform it to degrees, we're going to divide by 3,600 minutes or seconds. And now if you do this calculation, you're going to have a value in degrees. So let's do that. I'll get 3,600 divided 32, 60 divided plus, and I have to add 73 plus. So the angle I get is 73.54 degrees. And now I'll do cosine of that and multiply by 234.78. Perfect. And I get that, let's say, results doesn't look very good. I'll say it results that x is equal to 66.52 meters. Perfect. Now we have to go to our initial equation here. In order to find the elevation at B, we have to add to elevation of height of instrument this distance x. This is what we're going to do. So we have 565.23, which is the height of the instrument or the elevation at height of instrument, plus x, which is 66.52 equals. Now let's do that. We're going to add 565.23 plus, and I get a value of 631.75 meters. Okay, and this is the elevation at B, 631.75. Let me write it down again, is 631.75. And the option, correct answer is D, 631.75 meter above sea level. Perfect, let's move on. Next problem. The table below shows data for a closed traverse ABCD. All necessary closure corrections have been applied. What is the bearing of line AD? All right. Let's see how we're going to approach this. So we have the bearing, we have the length. We have to calculate the bearing of line AD. So we need to calculate this information over here. Okay, in order to do that, what we're going to have to do, we're going to have to find a few more information here. And this is why I left this empty. We're going to have to find the northing and easting. And these values are going to help us find the length and the bearing of line AD. So let's start by, first I'm going to represent each line. Let's see, AB, the bearing of line AB is southwest. So if I have my, I'm going to place myself here. So southwest, northwest. Let me go a little bit on the side so it fits better. Maybe even get a different color. Let's see. Okay, so starting from here, I have AB as southwest 30 degrees. So I'm going to go this much. Okay. South, and this is west. Okay. And this distance, I'm told, is 561. So I'm going to write it here. 561.87. And the angle is south 30 degrees, 11 minutes. Let me quickly do the form of degrees. So I have 8,3600 divided. Then I have 1160 divided. I'm going to add them up. And then I have 30 plus. So the angle I get here is 30 degrees, 18555. So I'll do 3186 degrees. See, maybe the angles, I'm going to represent them in a different color. So I have, also delete this. I'm going to present the distances and the angles in a different color. So I have the distance is 561.87. And the angle is 30 degrees, 186 degrees. Great. So this is line AB. AB. Perfect. Now let's represent BC. BC has 1,023.65 feet. And the bearing is north 28, 41, 38. So it's northwest. So it's going to be going kind of this direction, 28 degrees. If this is my north, this is west. I have 28 degrees. Let's see, I'm going to go all the way up like this because it's longer. So this is BC. And the distance, I'm going to write it down here with the same color, is 1,023.65. And this angle is, let me calculate it again. I'll do 3,600 divided. Next, I have 4160 divided. Gonna add these two values, 28 plus, and I get 28,693.88. So I'll write down 28.694. 694. Okay, 28,694. Let's do here 28,694, just in case that's not very clear. And then this is 30, 186, 186. Great. Next, let's represent CD. CD is having the bearing northeast. So northeast, that is going to be in the first quadrant. So if I'm situated at C, let me get the dark line. So if I'm situated here, northeast, this is going to be north, and this is going to be my east. And the line, the angle is 73. So I have to go, there you go, something like this. The distance is 600. Let's say something like this. And the angle is this one over here. And the angle is 73. Again, I'm going to calculate it in degrees, so I have a better, easier. So it's going to be easier for me to calculate. So 22 divided by 3600. And then I have 16 by 60 divided. I'm going to add these two values and then I add 73 to this. I get 73.273. So this angle is going to be not 27, but 73.273 degrees. And I wrote it in black, and I said I'm going to write everything in this color here. So the angle is 73.273 degrees, and the distance is 653.67. Perfect. Now I'm going to go back to this. So now this is CD. Okay, this is D. And DA, it's going to be this line if I was to connect these 2 points. This is going to be DA. Perfect. So now what we're going to do, we're going to calculate northing and easting for each line, AB, BC, CD. So let's start with AB. What is northing and what is easting? I'm going to get this green color. So AB, this is going to be the easting, and this is going to be its northing. We have, or actually, let's come here. We have that angle. This is going to be easting, and this is going to be the northing. Let me take this away. There you go. So northing and easting. There you go. From this right triangle, we have the angle, we have this distance, hypotenusa. We can easily calculate these two distances. So northing, this is going to be the northing. I'm going to put an N, and this is the easting. So let's see. We're going to use sine and cosine to do this. So the easting is going to be equal to sine, I'll say 30.186 sine multiplied by 561.87 multiplied. So I get a value of 282.513. Now, another thing we have to remember is this AB is in the third quadrant, and we have to go back to the FE handbook and see what is the northing in the third quadrant. And it seems like it is negative. So we have to, or this is the easting we're calculating here. Yes, we're situated in the third quadrant, AB in the third quadrant over here. And in the third quadrant, we have departure and latitudes as negative. So in our case, the departure, we have calculated it, is negative. So we're going to say that I got 282 with a minus in front, 282.513. Now let's calculate, and I'm not sure, I'm not gonna have a lot of place to write down because I would like to write this down for you. So I'll say AB, let's say line AB. And what I did, I said that the easting of AB is equal to 561.87 multiplied by sine of 30.186. And I got minus 2, I got 282.513. And in the table, I added the minus sign because, as we just talked about, the line AB is situated in the third quadrant, and the departure is negative in the third quadrant. So we add a negative sign to it. The same, well, let's look at the northing. AB, we're going to have, let's say, northing of AB. It's going to be equal to 561.81 multiplied this time by cosine of 30.186 equals, come back to the calculator, we're going to say 30.186 cosine this time, and we're going to multiply with 561.87. I get the value of 485.679. Okay, again, going back here, we know that the latitude in the third quadrant is also negative. So we're going to add it in the table with a negative sign. Northing is 485.679. Okay, now we're going to do the same for line BC. Let's see, BC. I'm going to do easting of line BC equals, and then northing of BC equals. We're going to build our triangle. Here, this is the right triangle. We know the angle, 28.694. We know this distance. Let's go ahead and calculate for the northing and easting. So first, I'm going to start with easting, which is this over here. This is easting. This is northing. Easting is going to be equal to, again, to sine because it's opposite to the angle. So we're going to have 1023.65 multiplied by sine of 28.694. And then northing is going to be equal to 1023.65 multiplied by cosine of 28.694. Let's use calculator and find out these two values. Okay, 28.694 sine 1023.65 multiplied. This equals to 491.487. 487. And then let's look at the quadrant here. We're going to be in the second quadrant. We're going to be here. The line goes up like this. In the second quadrant, let's pay attention. Departure is negative, which means easting is negative. And the northing or latitude is going to be positive. So in our case, we have just calculated the easting and it is negative. So we're going to have to add minus when we add it here in the table. We're going to say minus 91.487. Great. Now let's calculate for the northing. So the same way, 28.694 cosine 1023.65 multiplied. I get a value of 897. 897.942. 942. And now we're going to add it in this table, and it's going to be a positive value for northing. 942. As we said, northing or latitude in this quadrant is positive. Moving forward, now let's take line CD. Line CD has the angle of 73.273. So let me write this down. I changed the color to make it a bit more clear. So CD now, we're going to calculate the easting of CD. It's going to be equal to, let me build the triangle here. I'm going to build it like this. And this is the right 90-degree angle. And so this is going to be the northing now. This is easting. And so again, easting is going to be equal to, let's take the length as 653.67 multiplied by sine of 73.273 equals, and then northing of CD is going to be equal to 653.67 multiplied by cosine of 73.273 degrees equals. Let's use our calculators and calculate that pretty quick. 73.273 sine, and now 653.67 multiplied. I get a value of 626,011. 626,011. And then northing is going to be equal to, again, 73,273 cosine this time, multiplied by 653.67. And the northing is equal to 188.134. Now let's check the signs for this. CD is in first quadrant here, and check in this first quadrant, the departure and latitude are both positive. So these values are going to be entered here as positive. I have easting 626, 6.011, and then northing 188.134. And now, in order to calculate the northing and easting for line DA, we're going to have to use a property about northing and easting that we know. And it is the fact that for a closed traverse, the sum of latitudes is equal to 0, and the sum of departures are equal to 0. So let me write this down somewhere here. I'm going to say sum of northings equals to 0. So from this property, I'm going to get results that minus 485.679 plus 897.942 plus 188.134 let me delete this, equals 485.679 minus 897,942 plus 188.134 plus, and I get a value of 600.397. So going back to my first property here, in order for this to be 0, the northing for line DA has to be negative of that. So I have to get minus 600.397. Again, I hope you understand where this comes from. I'm going to repeat. So the sum of northing, or the sum of latitudes, needs to be 0. This is a property for a closed traverse. So we have only 3 values. So in order to calculate for the first values, we're going to add this up. And whatever value we get, we're going to put the negative of that, or the opposite sign of that, in order for, now if I am going to all add them up, I'm going to get the sum of this as 0. The same thing we're going to do with the eastings. The sum of eastings is supposed to be equal to 0. And from here, I'm going to calculate the value for the easting of DA. So I'll get minus 282.513 minus 491.487 plus 626,011 equals, let's see what we get here. Do 282.513 negative 491.487 negative. I'm going to add this up. And then I get 626.011. Add this up. So I get a value of negative 147,989. So in order for this to be 0, it means that the easting for line DA has to be positive, that 147,989. So now if you add them up, you're going to get the sum of eastings equal 0. Perfect. So now we have this. Let's see if we can represent that. Northing and easting of line DA. See, I get this and this. This is 147.989, and northing is 600.397. Great. So now that we have these two distances, we have the easting and we have the northing of line DA. How can we find this angle here? Let's call it theta. We know that if we apply the tangent in a right triangle, the tangent uses the both catetas. So here I'm going to say tangent of angle theta is equal to, tangent equals to opposite over adjacent. So I'll have 147.989 divided by 600.397. So from here, we can calculate theta as equal to tangent minus 1 of this value. Let's see what that value is. I can actually write it down. I'll say tangent of 1, or arctangent of 147,989 divided by 600 397. And let's calculate theta. I'll get 147, 989, 600, 397 divided. And now this value, have to do arctangent of this value. So do this arctangent of that. So I get that angle theta is equal to 13.8465. So I'll do 1385. I'll approximate it, degrees. So here we found 1385. Now in the options, I'm given the value in minutes and seconds, but that's all right. Let's first figure out if it's northwest or southwest, because we have two values with 13, northwest and southeast. We are asked, what is the bearing of line AD? So AD, not DA, okay? So now, since we have AD, because it's different for AD and DA. So AD, it's very important, pay attention to the question and the problem. AD now, it's gonna be, the bearing is gonna be north, right? And going west. Northwest, this angle 1385. North, 1385 west. So the bearing of line AD, so AD, the bearing is going to be north, 1385 degree west. So this is my final answer. Perfect. So now looking at this both options, I see I have northwest, southeast. Obviously, the correct answer is going to be B. North 13 degrees, 50 minutes, 44 seconds, west. Great. We're done with that. It was a little bit of more work, but I guess if you don't have to write this thing down, just do cosine sine of each. And then we used also the property of the fact that latitudes, the sum of latitudes equals to 0 in a perfectly closed traverse, and the sum of departures is 0. And then we found latitude and departure for line AD. And from there, we calculated the angle theta by applying the tangent property in a right triangle. Great, let's move to the next problem. Points A, B, and C are key points on a traverse. The distance from A to B is 387.65 feet, and the bearing of line AB is south 75. Again, here, 75 degrees, 45 minutes east. The distance from B to C is 712.12 feet, and the bearing of line BC is north 25 degrees, 30 minutes east. What is the length of line AC? Okay, let's again represent this to have a better understanding of what we have to calculate. Let's start with the overall thing. We have 3 points, A, B, and C. We know the distance from A to B and the bearing of A to AB. So let's start with the bearing. Is south 75 degrees, 45 minutes east, southeast. So line, I'm going to start here, southeast. There you go. This is going to be A, and this is B, and we have south, and we have east. And this angle here is 75 degrees and 45 minutes. And the distance of this line is 387.65. Okay, we're done with line AB. Let's move to BC. We know the distance, and then the bearing is 25 degrees, 30 minutes east. Starting from B, we're gonna go northeast. So northeast, place us in the first quadrant. We're gonna go northeast 25, approximately 25 degrees. So I'm gonna do this. And the distance is 712.12 feet. And this angle, this angle over here is 25 degrees and 30 minutes. And this is point C. Okay, and now we have to calculate the length of line AC. I'm going to connect A and C, and we have to calculate this length. Now let's pay attention to what we have. We have angles and we have distances. We know this angle is 25 and 30 minutes. This one is 75. Okay, so if I have these two lines, which are parallel lines, which means that this angle is equal to this angle over here. So this is also going to be 75 degrees and 45 minutes. And I use the property of, I think it's called alternate angle. When you have two parallel lines and intersected by another line, these two are equal. So now we have, let's see, we have the value for this entire, we have this angle, angle B. And the reason I need that angle, what I'm going to use here, I'm going to use one of those sine cosine laws, because we have distances, we have the angles, and let's see what else do we need in order to use one of those properties. I'm going to go to math. Well, let's see if I say law of cosine. Let's see if that's the way it's presented. There you go, law of cosines. Perfect. So I'm going to, in order to use law of sines, I need the distance and the opposite angles. And in order to use cosines, let's see, for the cosine, I have to find a distance. So I'm going to use cosine because I have to calculate a distance. So if I was to use a squared, let me write this down. So I'm going to make this B. So this is my B. This is A. This is C. And then this is angle A, C, and B. So in my case, I have to calculate B. So I'm going to use this B squared. Let me write this down. I'm going to write it here. B squared equals to A squared plus C squared, A squared plus C squared minus 2AC. Okay, cosine of B. Cosine of B. So B, angle B, let's calculate it here. Angle B is equal to, so we're going to have 75 degrees, 45 minutes plus 25 degrees and 30 minutes. And I guess, why not? Let's do a little bit of exercise of transforming minutes into degrees. This is going to be 75 degrees, stays the way it is, plus 45 minutes divided by 60 minutes. And now this is value, it's going to become degrees, plus 25 degrees plus 30 divided by 60 minutes equals. And now angle B equals 2. Let's use calculator quickly. Have 30, 60 divided 25 plus 45, 60 divided plus 75 plus, I get that angle B equals to 101.25 degrees. Perfect. So now let's see, we have A equals to, A is equal to 712.12, and then C is equal to 387, right? From here, 387, this value, 0.650 or 65.65. Okay, perfect. I think we should just come back here and we're gonna substitute. I'll do B is equal to, I'm gonna take square root of, and let's substitute to have 712.12 squared plus 387.65 squared minus 2 multiplied by 712.12 multiplied by 387.65 and multiplied by cosine of 101.25 degrees. Okay, let's take the calculator. This is a matter of calculating this now using our calculator. So I'll have 712.12 squared, and then I'll have 387.65 squared plus, I'll leave this like that, and then I'll calculate the rest now. I'll say 101.25 cosine, 387.65 multiplied 712.12 multiplied 2 multiplied minus square root of that 874.698. I'll do 0.7 feet. So I do get 874.7, and I guess this is supposed to be 874.7. There's a mistake there. So I guess the correct answer is going to be C, 874.7. For some reason, that was not correct there. Anyway, you got the idea of how to solve this. We use the law of cosines. Great. Let's move forward now. We have, I believe this is our final problem for today. A closed traverse ABCD is described below in terms of coordinates, northings and eastings of stations A, B, C, and D. What is the area of the polygon ABCD? Okay, every time I hear about a polygon with coordinates, I think of area by coordinates. So this is what I'm going to use today. And area by coordinates is given to you in the FE handbook. If we were to go to surveying, and remember I told you surveying is under civil engineering all the way at the end. So I'm going to go to environmental and just scroll up a little bit. Here it is. And we have area by coordinates, a formula given to you in the FE handbook. And we're going to use this formula. So we have ABCD. This is A. I just randomly gonna represent it like that. C and D. And A has the coordinates. Eastings is a X value, so minus 350 and 5 20. B is gonna be 350, 850. Now C is gonna be 950 and minus 450. D is gonna be minus 1150 and minus 700. Okay, now let's come here and we're gonna write the formula for area by coordinates. So the area equals to, I'm gonna say XA multiplied by YB minus Y. And pay attention here, we have YB minus YN. You know what, I'm gonna write it YN for now. YN plus, we're gonna have XB moving forward, YC minus YA, YC minus YA plus XC. Let's see what is in here. YD minus YB, YD minus YB plus XN, YA minus YA, YN minus 1. So YA minus YN minus 1. And all this divided by 2. A little bit squeezed, but we do understand what's written there. Divided by 2. Okay. So the reason I wanted to bring it out here, because I want to pay attention to what's going on when we apply this formula. So let me do a green. So I'll have XA multiplied by YB minus YN. YN in our case is actually D. So I want you to pay attention to the pattern, right? So we're going to have the area is equal to 1/2 multiplied by XA, which is minus 350, multiplied by YB, 850, minus YN, which is in our case minus 700, so plus 700. Okay, next we're going to have plus XB, which is this guy over here, 350. Multiplied by, and now what's happening? YC, we're moving forward with the YC, which is minus 450, minus YA, 520. Plus XC, now this guy, XC 950, multiplied by, moving forward by YD, this guy over here, minus 700, minus YB, which is 850. There you go, plus, and we have our last point, plus XN, which is XD. So it's negative. We're going to just say instead of plus, negative 1150, multiplied by, we move forward with the YA 520 minus YC. Our N minus 1, in this case, since D is the last point, N minus 1 is C. So minus with minus is going to be plus 450. And close the square parentheses. And this is the area of this polygon. All we have to do is calculate all these numbers, and hopefully I enter them correctly, and hopefully I will calculate it correctly, and hopefully we get one of those answers. Let's start. Okay, pay attention to the signs. Okay, 850, 700 plus 350 negative multiplied. Okay, that's done over there. Next, I'll do 450 negative, 520 negative plus 350 multiplied. So I get two negative values. I'm going to add them all up. Okay, so I'm done with this. I'm done with this. Now let's move forward. I'll have 700 negative value, 850 negative value, add it up, and then 950 multiplied. Okay, and now we have to add up with the rest of it. So I'm going to add it up. I'm done also with this. Perfect. Okay, I'm gonna enter, get a 2 million so far, 2 million something. Now let's try and find this last parenthesis here. So I have 520 positive value, 450 positive value plus, okay, 1150 negative value, multiply, and now plus. So I get minus 347 0 0 0 0. So 3,470,000. And these are square feet. And the negative value doesn't matter because an area is not negative or positive. So now pay attention, we have to transform this into acres. Let's go to the FE handbook and go to units. Okay, I'm gonna go downward a little bit. So here on this page, all the way at the top, the first unit is multiply acres by this number to obtain square feet. In our case, we have square feet and we need to obtain acres. So we're going to have take the square feet and divide by this number to obtain acres. So 3,470,000, okay, divided by 43,560. Oh, you know what I did? So I got this number, but I forgot to divide it by 2. Okay. All right. 3,470,000. Okay, because this number, I got it right, but I forgot to divide it by 2. So let's fix that. I'm going to delete this. So square feet, correct. But first, I'm going to divide it by 2. Okay. Okay, 2 divided. So the area of this polygon is actually, I'm going to keep the negative, I guess. 1,735. 1,735,000 square feet. Okay, so this is the area of this polygon in square feet. And this, so the area, now we have to divide this by this number, as we just talked about. So now I'm going to take this number divided by 43,560, and I'm going to get 39.83. And now these are acres, my friends. There you go. Okay. 39.8. A is the correct answer. And that is it for today for part 1 in surveying. Next week, we're going to work on a few other problems. As always, if you found this video helpful, please subscribe and give it a like and comment below, because this helps put this video in front of more people like you. I hope you're having fun working on these a few problems. I will see you next week.